from, again, page 53, number 1. Okay, what we're looking at here are these parallel lines. Now, with all these parallel lines that we have, the one thing we do have, and we should remember, is what do we remember or know about like this angle and say that angle? This angle right here, and that angle right there.
They're the same.
They're the same. They're equal because they're corresponding angles. You have parallel lines. So with parallel lines, we get a lot of congruent angles. Now what we're looking at is these side lengths that parallel lines can break lines into. So for instance, what I'm looking at is I have all these parallel lines, and they broke up this side and this side into certain lengths. These lengths won't be the same because the angles that are made, like this angle right here, is different than this angle over here where they cross the parallel lines. But what we do know is that they break them up proportionally. So if they break up these proportionally, it's pretty easy to find, say, x. Now x, I think, is one of the easier ones to find because since we have 2 and 4 here, and this is 3, what should x be?
6.
Yeah, we could just double the 3 and get 6. Now some people have already kind of made a false idea of that you add the same amount. You're actually multiplying by the same amount. So since it's times 2 here, you can times 2 here. Pretty simple idea. Okay? Now, that won't always be that easy because you're not always going to be doubling or tripling. So if we look at, say, these sides, we have a 3 and a 2, and a u and a 3. We can actually set up proportions. So to find u, I would actually do 3 over 2 equals u over 3. Okay? So you should make sure that you line up these numbers. And what I mean by that is if you go 3 over 2, make sure that you jump up to the top line again across from that 3. So u is across from 3, u is across from 3. And yeah, you should get u equals 4.5 through cross multiply and divide. So 3 times 3 is 9, divided by 2, 4.5. Okay, so we can write that in there. All right. Okay, now if we look over here at, say, m, we have m and n. Right away, what do you see about m? What should m be? 5. How'd you get that?
It's half of 10.
Right, so if you notice, all these parts, 2 is half of 4, 3 is half of 6, so 5 should be half of 10. And you could use the 2 and the 4 or the 3 and the 6 because these are all going through those parallel lines.
You can figure out n. Could you do 5 over 3 equals n over 5?
Yeah, so you could go 5 over 3 equals n, 5 over 3 equals n over 5?
Yeah.
No, you're close. If I went 5 over 3 equals n over what?
6.
4.5.
4.5. It looks like
Yeah.
5. The way you wrote it looks like 5.
Yeah, it's a 4.5. So you can go 5 over 3 equals n over 4.5. And cross multiply, divide by 3. When we get there? 7.5. Take your word for it. Okay. Yes, Timlin.
Could you do 3 over 4.5 is equal to 5 over n?
Yes, you could go 3 over 4.5 equals 5 over n. You could do 4.5 over n equals 3 over 5. Okay, there's a lot of different proportions you can set up, and all those work. Yes?
Could you do 3 over 4.5 is to 4.5 over n?
3 over 4.5 is 4.5 over n.
No, the other piece on the other side.
Oh, over here. So 3 is to 4.5 as 4.5 is to n. That, no. No. It might work on that one. Does it work on that one?
Yeah.
I don't know.
Because it's 0.6.
So that might work on that one, but I don't think it'll work here because I'm looking also at, if that's the case, then 2 over 3, which is 2/3, would have to equal 3 over 5, which is 0.6, not 2/3. So yeah, that wouldn't work directly there. Okay, now the last one we have here is the y. Now the y was kind of difficult because I don't see any transversals that go through here like this situation. I figured, well, I have these numbers 3 and 5 and y and 2, so maybe intuitively as far as solving problems, I should use a 3 and 5, but then it kind of got me thinking of y. So I'm like, why can I use that? It's not really, I know I have these parallel lines that go here and here.
It just kind of like flips.
Yeah, it kind of flips over. I was thinking it kind of flips over, and maybe these flip over to go here, but then I thought again, I thought, well, it's not necessarily going to flip over. They could flip over and go in this direction. So I thought more and more about why, and since these guys meet the same spot here, here's what I was thinking. Since we have, say, let's take these parallel lines up here. If I drew a perpendicular line here and a perpendicular line here, assuming that they're both perpendicular, those line segments I drew, that distance between the two lines should be equal, right? Because they're parallel. So the distance between the two lines are parallel. It's the whole idea of parallel lines is the same width all the way, forever. So I took that same idea here. If I took, say I drew this width between those two parallel lines, that should be equal to this width because they meet in the same place here. And if I take it a step further, what if I cut this? Oh, that's not a very good cut. Let's do that. I cut it perpendicular like that, and I cut it perpendicular like that. Wouldn't those line up? Like, wouldn't those two cuts, could I take this and move it there? And I kind of have like this picture look like this. And then this would be the 5, and this would be the 3. You see what I'm saying? So that's intuitively what I thought about, is about cutting those pieces out right here, moving it there, and I still get my proportion that I want. So it'd be 5 over 3 maybe equals y over 2. So y equals 10 thirds, which is 3 1/3. And there's a lot of ways you could have done it.